So in this part of the lecture, we will talk about the difference between speed and velocity. Mechanics is the oldest branch of the physical sciences, and it is the study of objects. When we describe motion, we are dealing with a part of mechanics that is called kinematics, which is from the Greek word for motion. When we analyze the causes of motion, we will deal with dynamics from the Greek word of force, such as dynamite. Kinematics is the branch of physics that describes the motion of an object. By specifying the position, velocity, and acceleration of the object, we can describe pretty much everything that we need to describe for kinematics. How the object moves, the direction of its motion, how the direction changes with time, whether the object is speeding up or slowing down. So how do we do this? Well, we describe motion of a particle in a number of different ways. We can define it as mathematical equations, or we can define it graphically. So mathematical equations are better for solving problems. It permits more precision. The advantage of graphical representation is that it provides more physical insights than a set of mathematical equations. So for this course, we will use both methods here. So now the question is, what are we actually measuring when we talk about the study of motion? Well, the first thing that we do is we will measure the distance traveled, we will measure the time taken to the distance, and we will also tell you the direction that you moved in. So all these three combined together can tell us the motion of the particle as it is now, and it also helps us to extrapolate further where the object is going to be, say in a minute or in an hour or in 2 hours, if it continues to do the things that it is doing right now. What is speed? Speed is the rate of change of position. Speed is the ratio of the change of position, and it is the magnitude of a velocity. It is a scalar quantity. So in order to define average speed, you will take your distance traveled divided by the time taken to travel that distance. Velocity, on the other hand, is the rate of change of position. Velocity is a vector that measures how fast something is moving, and it also tells you the direction of the motion. In one dimension, the average velocity is given by delta x over delta t. So in fact, it is actually the change in displacement with respect to time. So average velocity is the speed and the direction combined together. Velocity is the rate of change of displacement. Velocity is a vector that measures how fast and in what direction something moves. So in fact, velocity is the rate at which the displacement occurs. As we talked about in the last lecture, displacement and distance are two different things. So be very careful. Velocity measures displacement, speed measures distance. In one dimension, the average velocity is given by the rate of change of displacement with respect to time, given by this equation here. The SI unit for both velocity and speed are meters per second because they both measure how much displacement or distance something has covered with respect to time. The average velocity is basically given by the slope of a chord on any graph. So if you have x on your y-axis and your time on your x-axis, and this is how your object, your car, your plane, whatever you have is moving, then in order to find the average velocity between any 2 points, you would draw a chord from the initial position to a final position, and that will help you find what the average velocity is. So in fact, in this case, it will be x2 minus x1 divided by t2 t2 minus t1. Instantaneous velocity is the velocity of any instant. By definition, it will be defined in the limit when delta t, which is a change in time, goes to 0. Instantaneous velocity is represented by the slope of the tangent to the curve on the graph of the object's position versus time. So now, graphical representation of motion. In order to define graphically the motion of any object, we will talk about two different things. One will be constant velocity and the other one will be increasing velocity. For a constant velocity, the graph looks something like this. For an increasing velocity, the graph will look something like this, where if you will notice that the gaps or the distance between these points remain constant as time increases. Whereas if you are speeding up, the distance traveled here will be more than the distance traveled here. So this graph is now a representation of an increasing velocity graph. So now let's look at how we will look at this graph and mathematically calculate for constant velocity. So by definition, the constant velocity will be given by delta y over delta t. If you have a constant velocity, your graph will look something like this. Now, in order to calculate and actually prove that this is a constant velocity, let's look at the path dE, which I've randomly chosen as the distance between these 2 points. Now my delta y for this case is about 15 centimeters and my time is about 0.2 centimeters, which gives me 75 centimeters per second always convert to SI units, which gives me 0.75 meters per second. Now choose another path, A to C, which is represented by this curve in the distance versus time graph. If you were to find the average velocity, it will be 45 centimeters divided by 0.6 seconds, which gives me 75 centimeters per second. Now compare the path DE to a path AC. They have the same value, which implies that this is a constant velocity and velocity is not changing between the distance versus time graph. On the other hand, for increasing velocity graph, the graph looks something like this. So in this case, if you were to take the path DE between these points, the delta y over delta t will come out to be 0.37 meters per second. If you were to take a path GH, your path will be 20 centimeters divided by 0.818 seconds, which gives me 1.1 meters per second. If you've noticed, 0.37 and 1.1, there is a difference. It is an increasing velocity. On the other hand, if you were to take path A to B and try to find the average between them, this will give you the average for all of these points, which comes out to be not as fast as 1.1 and not as slow as 0.37, but it averages out to be 0.16. So this represents an increasing velocity graph where if you take different parts of the graph, it will have different values for velocity. Try to think what a graph of decreasing velocity would look like. An important thing to note when we are talking about average speeds and average velocities and so on and so forth, the average speed is not related to the magnitude of the average velocity. So for example, Indy 500 car race has an average velocity of 0. We know its speed is not 0, right? But its average velocity for the cars is 0. And why is that? The reason why that is because all the cars will start and stop at the same point. If a car starts and stops at the same point, its net displacement is, you guessed it, 0. If the net displacement is 0, its average velocity is 0. No matter what you do with your speed, if your displacement is 0, your velocity is 0 for that graph.